number 20. In question 20, we're being assessed on how to identify exponential relationships from tabular representations. Okay? Alright, so in this particular problem, we're given 4 tables, and the question is, which table best represents an exponential relationship? Okay? So, in order to answer this question, we just need to know what to look for. Now, this is the deal. We need to remember how exponential functions grow. Alright, so recall the following. This is very important. Recall that output values of an exponential function or relationship, the output functions are generated by what? By repeated multiplication. That's what exponent is, right? If you if you multiply repeatedly, that's what exponentiation is. So they are generated by repeated multiplication. Alrighty. So if you have the exponential model y equals a b to the x, this is generated by what? It's generated by multiplying by the base of the exponent, multiplying by b repeatedly. Okay, so let's go ahead and examine this table. We're going to examine the growth rate of these tables and see which one demonstrates this pattern right here, where we are multiplying the output values by the same constant repeatedly in order to generate consecutive output values. Okay? Alright, so let's take a look at the first one, the first table. So how are the output values going? Is it by multiplying by a constant? Is it additive, or what's going on here? So from 8 to 4, what's the growth rate? The growth rate, you just basically divide, right? So if you want to find the growth rate, if it's being multiplied by, you just take the second term divided by the first term. So 4 divided by 8, which is 1/2. So in order to go from 8 to 4, you multiply by 1/2. Okay? How about to go from 4 to 2? How do you go from 4 to 2? 2 is half of 4, right? So we multiply by 1/2 again. Oh, look at this. From 2 to 1, you multiply by 1/2. And then lastly, from 1 to 1/2. So in this particular table, in table 1, we're multiplying by the same number repeatedly. The number in this case is 1/2. And what is that? That is what an exponential relationship is. Okay, so the answer to this question is option number 1. Alright, so now this is a challenge. Can we determine what the function is? Can you look at this table and determine what the function is that generates this table? Well, this is just an add-on. So let's go ahead and see if we can do that. Now, for an exponential relationship, the general formula, the formula is y equals a times b to the x, as illustrated here. Okay, so we have the formula y equals a times b to the x. So using the coordinate 1, 8, the first point, and the fact that the growth rate, this is the b right here, b is 1/2, we can we can basically determine what the a value is, and then we just generate the formula. Okay, so these are x and y, and b, all we need is a. So y is 8, a is unknown, b is 1/2, because that's what we're multiplying by over and over again, the growth rate, the growth factor, and then x is 1 because we're looking at this at the first coordinate pair. All right, so if we do that, we are going to have 8 is equal to half a, and then to get a isolated, we multiply both sides by 2, and then our answer is going to be a is going to be 16. So that tells us that the exponential model for option 1 is y equals 16 times 1 half to the x power. So this is the exponential model for table 1. Alright, how about table 2? What's going on here? If you take a look at table 2, now you ask yourself, what number can you multiply 0 by to get 1? What's the factor here? The answer is there's no number that you can multiply 0 by to get 1. It's impossible. So we can see that this is automatically not an exponential relationship. And then for the third one, how do you go from 0 to 1 by multiplying? Impossible. Okay? And then in 4, you can go from 1 to 8 by multiplying by 8, right? How about if you want to go from 8 to 27? You got to multiply by 27 over 8. How about from 27 to 64? You multiply, so you divide by 27 first, and then multiply by 64. So 64 over 27. And then it just basically helps you to see that we are not multiplying by the same number over and over again. Okay, and then the last one is you multiply by 125 over 64. Ladies and gentlemen, this clearly is not an exponential relationship because we're not multiplying by the same number. Alright, so question 2, do you know what kind of function question 2 is? If you notice, we keep adding 1, 1, 1, 1, okay? So whenever you're adding a constant, that's a linear relationship. This is linear. And from this one, if you think about a linear relationship, you have the formula y is equal to mx plus b for a linear function. In this particular case, the y-intercept is 8 because when y is 0, x is 8. So b is, what is b? 8. And then, oh, sorry, I got that backwards. For the y-intercept, you set x to 0. Okay, so the y-intercept here is 2. Okay, so this is the y-intercept. You look for where x is 0. Okay, so the y-intercept is 2, and the slope is how much you grow by. So in this particular case, we're always adding 1, right? Okay, so our m is 1. So the model for the second one is a linear model, and it is basically y equals mx plus b, 1x, so just x plus 2. Okay. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for your upcoming Algebra 2 exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions, comments, or special requests, just post it in the comment section below and we'll be more than glad to respond. Do not forget to subscribe to our video for updates to the remainder of this review series. And also visit our website, mathgotserved.com, on the New York regions for access to the transcripts to this video and other great support resources. Thanks again for watching and have a wonderful day. Goodbye.